This is our Earth, which has a population of about 7.7 billion people. Here, more than 3 billion people use computers, so errors are prone to occur. Errors occur whenever data is stored or transmitted from one part of the computer to another. Well, imagine, what if your teacher sends you an email saying that you will now get extra marks for your project, but some error occurs and it changes to you will not get extra marks for your project. Such a bummer, right? That is why error detection is important, and hence we use certain error detection methods. These methods mean adding some extra bit to the data being transmitted that helps detect errors. There are various error checking methods like Parity Check, checksum, etc. Today, we will be focusing on Parity Check. So, let's start with a fun magic trick. I want you all to meet my assistant Bob. So, here on the screen, I have a 5x5 grid and I have asked Bob to randomly color the squares. Then, for my convenience, I have added a 6th column and a 6th row to the grid. Then using my calculations, I have colored some squares in these two rows and columns. Now, when I am not looking, I asked Bob to remove any one colored square from the grid. And with my magic and heavy calculations, I can easily locate the changed box. Well, relax. This has nothing to do with magic. It is simply done using the even parity method. Each colored square is given the value of 1. And we will start with the first row. It contains even number of ones, so the last block is blank. The next row contains odd number of ones, so the last block is colored. The third row contains even number of ones. However, the last block is colored. This means that there is an error in this row. Now, we will go on to identify the wrong columns similarly. The first column has even numbers, so the last block is colorless. The second column, however, contains odd number of ones, and yet the last block is colorless, so this column has an error. Therefore, the incorrect block is the intersection of the incorrect column and the incorrect row, which is right here. Now, not only can these methods detect the errors, but they can also correct them. So, this block, which has a value of 0, is now flipped and turned to have a value of 1, which makes the whole process correct. Now, let's take a look at some of the real life uses. Firstly, parity is used in barcodes. Barcodes are codes that are made up of a series of dark and light lines, where light lines have a value 0 and dark lines have a value 1. Here, the left side begins with a 0, ends in 1 and contains odd numbers of 1s, while the right side begins with 1, ends with 0 and contains even number of 1s. Another example is ISBN. Here, a check digit is calculated using the data and it is sent along with the data. It is recalculated on the receiver's end to detect errors. Now, let's have a quick summary of the video. First, parity check is an error detection method. There are two types of parity checks, odd and even. The parity bit is added to a string of binary digits. The parity bit can only be 1 or 0. The sender and receiver decide which parity is to be used before transaction.